Hello out there in YouTube land. This is tubalcain, Mr. Pete, your YouTube shop teacher. And this is part 2 of my series on the building of the 2x48 inch belt sander. And today we're going to actually get down to making some chips. Be sure and go back and watch part 1, which is an introductory and just telling you what the whole project is about. But today I'll start by machining one of the wheels, specifically the top wheel. Alright, the top wheel has 2 ball bearings pressed into it, so we'll begin with that. And that is this casting. However, I already have the other one in the lathe that is the cord hole, so it's ready to start drilling and facing. I cut a cross section just so you can see what they look like in the cross section. No need for this other than it's just interesting to see what's inside something. I like my cross sections, I like my cutaways, I think you know that. Alright, so again, the patterns made by Kevin Peterson. Thank you very much, Kevin, and these were 3D printed. Here are the bearings. Now, bearings are generally metric in dimension. However, I specially ordered these and they're a 1/2 inch bore, so the other dimensions are also imperial. Specifically, the outside is 1 3/8, that's 1.375 inches in diameter. So I need to bore that hole such that this can be pressed in. Now, I do not have a reamer that size, so I will have to bore it on the lathe. And then my whole idea of turning it will be to put it on this arbor, a homemade arbor, already turned, and I will use Loctite. As you can see, there's residue of the Loctite from the last project. Very easy to get off by warming it up. So that's how I'm going to hold it so that it'll run true. It's very important that these wheels run true or they're going to vibrate like crazy. Furthermore, since castings are really only semi-accurate in dimensions and all of that, I am going to machine the inside and the hub as well. Not the face here where my finger is, but those other 2 surfaces will be machined. That'll take any wobble or vibration out of it, because if you have 2 wheels vibrating upper and lower and maybe a little vibration in the motor, the whole machine is just going to walk all over the place. So that's my reason for doing that. Alright, let's go over to the lathe and make some chips. I'm at the Clausing 12-inch lathe and I have a 4-jaw chuck mounted, and the work is already being held with the jaws reversed. And I actually used an indicator on this, even though it's kind of a rough surface. So it's indicated in so that it's pretty darn close, very little run out. So since this is already a cord hole, I'm going to go ahead and drill it with, that's a little bit over 1 inch. I'm going to use this large drill bit, which is 1 1/16. We'll see how that goes. And it has a number 3 Morse taper here. I'll run that at slow speed. Remember, there's still a steel sleeve in there from that broom handle, so we'll see how that drills out. Now, this would be an ideal place to use a core drill. I have talked about core drills. Remember, core drills are designed to drill holes that have been cast into the casting, that is, at cord holes. So they're much more rigid and usually 3 or 4 flute, but that is something I do not have. So I'm going to go in with a regular drill, and then I will proceed to bore it. But even before doing that, I'm just going to take a light cut here. I'm going to face the hub and face the rim here. I want it to be about 2 and a 32nd wide. Right now it's about 2 1/8, so that gives me just enough material to shave a little bit off of each side. Alrighty, I'm down to dimension, so I'm just a couple thousandths under the diameter of the bearing to allow for the press fit. And this was turned to 2 thousandths less also, so that it will fit in there so I can put the Loctite on it and use that as an arbor. Now before I take it out, I want to take the boring bar and bore this true and this. I'll have to run the lathe in reverse to do this part. Then it's ready to take out and put on the arbor to do the other side and to do the periphery. Alright, the hole is bored, and I must say I got quite a good fit. This again is the arbor, and I'm going to Loctite that on. Let it sit overnight. I got plenty of other things to do right now. And see, that side is all turned and done, and tomorrow I will hold it in a 3-jaw chuck, or it might be a 4. Anyway, I'll get it trued up, and that'll give me the opportunity to face this side and bore that, and then start on the crown. So it's turning out quite nicely. I guess I didn't need all these extra castings, but you never know. You just never know. And got a real good start here with this bearing. It feels like it's going to go in. I press it, and I think I'll put some Loctite on these also when I install them for the final time. Now I had considered originally, instead of Loctiting it onto an arbor, holding it with a set screw. Now that may throw it off a balance too, but you can see here by the webbing that we don't have enough thickness here to drill a hole. And if it was a little bit off center, it would break out here someplace. So that's what I finally decided on. And it's quite a good method. So that this runs truly true. So that it runs true. Has to run true, or it's going to vibrate. Alright, I just cleaned the bore and the surface with some brake cleaner. It needs to be perfectly clean before you use Loctite. I don't need a whole lot. And it won't slip. Being mindful of what side needs to be out. I guess it will go right up against the shoulder. Alright. Looks good. I'm kind of tired. I'll see you tomorrow. Well, tomorrow has come, and I'm drinking my morning coffee, as you can see. And I now have the arbor along with the wheel mounted in a 4-jaw chuck, and I dialed it in to within about a 1/2 thousandth or so. So that's all ready to go, so it's going to run true. And the first thing I believe I'll do is to go ahead and face this off. And it's winter has arrived here in Illinois. But I want it to be, as I said, about 2 1/16 or 2 1/32 or so, just a little bit over 2 inch, although 2 inch would be all right as well. So I'm going to face this off as my first operation. I think everyone knows I'm extremely fond of this Schar's double-ended tool holder for both facing and turning. Does everyone understand why I am turning both the hub here inside and right here where the pencil is? Because even though these patterns, as I said, and castings are semi-accurate, watch how far out of true they are when I turn the machine on, and that would cause major vibration. Now, even though it doesn't appear to be a lot of wobble, at 3,650 RPM, it would vibrate, I guarantee. I received these boring bars from the Bartons, and that is Solid Rock Machine Shop, so we'll give this its inaugural run. It's brand new. I've marked it here, so I do not want any more protruding from the tool holder than necessary. That's what that mark is. That's carbide. Isn't that beautiful? Let's put it to use. And that produced a beautiful finish, and thank you to the Bartons. And now to machine the hub, and the machine will be run in reverse for that. I will not show that. You saw that last time. I think you know that I'm not working from blueprints. You discovered that by now. It's all in my head or taking dimensions from that Kalamazoo. So this upper wheel really wants to be somewhere in the neighborhood of 4 inches. Now the rough castings were about 4 1/8 or so. So I'm just going to clean this up, and I'm just turning it to the basic diameter now, and in the next operation I will crown the wheel. So let's go. I am now getting ready to crown the wheel. Do you remember what crowning is or was? It is the tapering 2 degrees from each side of a wheel or a belt pulley or whatever, and that causes the belt to track and to center itself on the wheel rather than to run off like you might expect. It causes it to center itself. So I've already marked the wheel right on the center, although I'll go a little bit past that. Now, when I made these in a recent video, I forgot the title, most of you have seen that. I did that with the taper attachment method, and many people ask me, well, can I do it with the compound rest method? Well, of course you can. In fact, that's what I'm going to use now. So I have very carefully and precisely set the compound for 2 degrees, and I will proceed to, again, I don't care too much about the diameter, but the problem with this method is that I have to feed by hand, no power feeds, and it's just a little irregular. But if I have a slightly rough finish, I don't really care on this because it'll polish itself. Plus, maybe there'll be more of a grip by the belt, especially on the bottom wheel. This is the upper wheel. The crown has been turned 2 degrees on this half. I had to relay out that center line because of course it was gone. So I have reversed the 2 degree on the compound here. So I'm going to feed, since this is a carbide tool, from left to right until I get to the line, right to the line, and I want the crown to be on the line. In other words, the crown should be in the center of the wheel, or the belt is going to track a little bit offside, which probably wouldn't be a big deal, but I'd like to have it correct. Just a minute or two with the map torch. We'll heat it up enough to remove the wheel from the shaft. Well, I put some more Loctite on the bore, and my plan is to run out to the garage real quickly and press these in with the arbor press. It's so cold, I'm not going to go out there with the camera today. It actually is snowing a little bit today, even though it's still October, so I'll press the bearing in from each side and that wheel will be done. Okay, the upper wheel is done. My finish leaves a little bit to be desired. And now I'm ready to start the lower wheel. And I'm not going to show all of that. I'm going to show the drilling and the reaming and perhaps the broaching, but certainly not any of the turning because it's just a repetition and it's just another size is all. There'll also be a set screw right here. Alright, I'm going to take a little break. Okay, the lower wheel is mounted in the 4-jaw chuck, and I did indicate it, and it's pretty darn close. However, because of the print, the 3D print, prints in segments, it's a little bit tricky to do the indicating because you got quite a bit of a fluctuation. But nevertheless, it's running pretty true. And now what I will do off camera is to go ahead and face the hub and face the rim right here. Then I'm going to drill it and ream it 5/8 to fit the motor shaft. And now to ream it 5/8. The hole is reamed, and what I've done is pressed a mandrel in there, a lathe mandrel, arbor. You can see it's 5/8, that's the large end. That's about as far as it's going to go, but that's all right because what I'm going to do is put this in the 4-jaw chuck, even though it's hardened, even though it's tapered ever so slightly, it's going to be all right, and indicate it in real true, and then perform my operations here, turning and all of that, and then I will reverse the arbor to do the other side because obviously there's not enough left there to hold in the chuck. So that's the game plan. Really, I believe you have to turn these on an arbor to get them to run true. Alright, the work is in a 4-jaw chuck and I've indicated it in within about a 1/2 thousandth, and I tell you, I'm not as fast at this as Adam is. In fact, I seldom use a 4-jaw chuck, but I'm within less than a 1/2 thousandth, which is better than it needs to be. So my next step, and I'm not going to show it, is to use this Barton boring bar and bore inside there. I just won't show any of that because it's all a repetition of the other wheel. If you are older than 60, you need both a magnifying glass and a flashlight to set your compound, and you can do it quite accurately. The 2-degree taper for the crown is done on this half, and now I am doing this half, and then this wheel is done. I'm struggling a little bit with surface finish here, so I did change the tool to a carbide insert that has a slightly larger radius. That helped a lot, but this casting is ringing like a bell because essentially it is a bell. So what I did here is I have a piece of lead left from when they built the nuclear power plant. I put that in there. That kind of stops the ringing, kind of like on a brake drum lathe where they do that, and it's held in place not only by centrifugal force but by some of this vile black substance that is used by electricians that looks something like this. Matter of fact, it looks exactly like that, so that holds it in place, but boy is it a mess. But anyway, that stops the ringing. And I believe this will be my last pass. I would like to take it to where the blue line is about gone, that is the center line, and I'm feeding from left to right because I seem to be getting a little bit better finish that way. Alright, that's as good as it gets, and you know, lead really is a good dampener, isn't it? It totally stopped that ringing. Well, I'm done with this. I need to remove the mandrel now. And even though the piece of lead did not wrap all the way around, I threw it out a little bit out of balance, but it wasn't perceptible. That's still glowing from when they came from the power plant. Or did I say that? Now, that black stuff, I think I'll take that off maybe with a brake cleaner. I got some on my fingers too. Alright, I'll remove that. I didn't quite take off the center line, but I was virtually down to it. So the crown is complete. 2-degree crown. Can you see that? I know you can. Now, of course, it's true that 99.5% of the people watching this video do not have the capabilities of casting these wheels, if in fact anyone would actually make this project. But of course, you can start with solid pieces of aluminum. That's way too thin and that's too small, but it can be done, but it would take you forever. And I much prefer turning cast aluminum over the rolled aluminum, which has just horrible curly chips. So there it is. I think I'll face that again. I got a little bit of something there I don't like. Again, thanks to Steve Barton and the Solid Rock Machine Shop for providing this nice boring bar. And that was used to machine in here. See what a nice job it did, and the hub here on both sides of both pieces. One more step, and that is to broach the keyway. So here's my set of broaches. Those are what? Hassey Savage Broach Company. There's the 3/16, which is standard for this 5/8 bore. Bushing goes in like that. Now, I'm not going to show this. You've seen that in many other videos, but I think everyone in all of Christendom knows what a broach is and what a broach does. Well, I'm back from the cold garage. Let's see, I gotta have something to tap that out of there. There's a 3/16 key, and it fits like a glove. Well, from these to these in 90 minutes or less, and if you think this video was long, you ought to have tried doing the project. I've been working on this for days. So anyway, that concludes this part of the video series on the building of the Kalamazoo type belt sander. Be sure and tune in to part 3 as I tackle the actual framework and other parts involved in this. So it'll be several more parts. I'm not sure how many. I got to find a motor first. So see you in the next video. This is tubalcain saying so long for now.